Okay, today we're going to talk about ways to prove triangles congruent. Okay, let's think back from last time. When the two triangles are congruent, how many parts did we have to show that they're congruent? How many parts? Raise your hand. Okay, Kevin? Six. How many people agree with Kevin? Yes. He is correct. Which 6 parts do we need to show that they're congruent? Yes. Yeah, the corresponding angles and the corresponding sides are correct. So, very good. Anybody want to read this for us right here? Go ahead.
If two triangles are congruent, the 6 parts of one triangle are congruent to the 6 corresponding parts of the other triangle. If you're not
Okay.
if you're not sure whether two triangles are congruent, however, it's not necessary to compare all 6 parts.
Yeah, it turns out today, last time, if you were to use a definition of congruent triangles, you had to show all 6 parts congruent. Okay, if you want to show that the two triangles are congruent, turns out you don't have to show all 3 parts. Okay, who wants to read the second part? Go ahead, Jason. From here, as you saw.
As you saw in written exercise 22, on the preceding section, sometimes 3 pairs of congruent corresponding parts will guarantee the 2 triangles.
Okay, stop right there. Isn't that nice? Sometimes it says 3 pairs of congruent corresponding parts would guarantee that 2 triangles are congruent. Why is that nice? Raise your hand, raise your hand. Why is it nice? Tony?
Because you don't need to figure out all 6 of them.
Yeah, you don't need to do all 6 of them. It cuts your work in half, right? Cuts down your work in half. Isn't that nice? So instead of showing all 6 parts, you could show just 3 parts. But you don't want to choose any 3 parts, right? By the way, which parts can you choose that would not guarantee that the 2 triangles are congruent? Because you can't just choose any 3. So which parts do you not want to choose? Yes. 3 angles. If you choose 3 angles, does it guarantee you that the 2 triangles are congruent? No, it doesn't. Who could explain why? Why wouldn't it guarantee you that? Nicholas?
Because the 3 angles, you could have any kind of length of the lines, because if you have one angle, you can move the other line in and out, and it will change the length of that one, but it's still the same angles.
Sure. Anybody want to add to that? That he's correct? Another way of saying is, anybody want to say it a little bit differently? Okay, give me an example. Can somebody give me an example? Yeah.
Like, you can make this triangle, and it has the same angles as like this triangle.
Exactly. Yeah, one could be smaller. It may look similar, right? But it could be smaller or bigger, right? They could all have the same angle measure. For example, if the angle is, I don't know, 30, 60, 90 degrees, okay? How many triangles could you draw that has angles measure of 30, 60, 90? Infinitely many. And are they all going to be congruent? No, some may be, but it doesn't guarantee you that you're going to have congruent triangles, right? Does that make sense? So then which 3 parts could we choose so that it guarantees us that the 2 triangles will be congruent? What's the easiest one that we could do? Yes, sir? Yeah, turns out you're exactly right. So this is our first postulate. It's called side postulate. We don't call it SSS, just call it side. So write this down. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. It guarantees you that the 2 triangles will be congruent if 3 sides of one triangle are congruent to 3 sides of another triangle. Okay, and here's an example. Okay. And as you can see from these, for first 2 triangles, you know that these 2 are congruent because of the markings, right? You know that AB is congruent to GF because it has 1 tick marks and then so forth. BC, GH, AC, and FH. The other one, they actually give you the actual length. Okay, so you can see that both pairs are congruent. You see that? So go ahead and write that down. Just the postulate. You don't have to draw the pictures, but write the postulate. Here. So who could tell me? Look at the first triangle, because it is important to say this in correct order. By the side postulate, you know that triangle ABC is congruent to triangle what? Raise your hand if you think you know. Young, what do you think? F, G, H. Is that the right order?
Yes.
How many people have a different answer? Because if you did, it'd be wrong. Okay, so he is correct. F, G, H. On your homework tonight, they're gonna ask you to do this. And the way that they ask you to do this is they're gonna say write the congruence. Okay, they're gonna tell you to write the congruence. And on the test also, I'm gonna say write the congruence. Many times people forget to do this. If I ask you to write the congruence, guess what? You're gonna write triangle ABC is congruent to triangle. And do you think when you write the congruence that the order matters? Yes, it does very much. Who could tell me? Who could state the congruence for this? Then triangle POE is congruent to?
It's cut off.
Sorry?
Like the other.
Oh, I'm sorry. Yeah, it is cut. Let me hold on. Let me move it. Yeah, now you can see it. Triangle POE is then who could state the congruence here? How about Nicole? RTY. How many people agree? RTY? I don't think so.
I'll just
I know.
You want to try it again? So first you have to look at which angle is corresponding angle to P. T, right? Because look, 3 is in the opposite side of P, right? And then so is T. So tell me what it is. Triangle T, R, Y. How many people agree with what Nicole said? T, R, Y? Anybody have a different answer? Because if you did, it'd be wrong. Okay, because this is correct. Triangle, oops, T, R, Y. There you go. Okay. Yeah, and then they try to. Okay, they try to do that. Okay, any question? But it's not, that's not the important part. They're not going to do this every time. Okay, so don't. Like ABC and FGH doesn't, Okay. Yeah, right. Okay, any question? Do you guys get that? Class, do you know what it means when they ask you to write down the congruence? Okay, do you know what it means then if I say that on a test or something like that?
Yes.
And of course, they're going to ask you which postulate can you use to show that the two triangles are congruent? What are you going to say for these? No, you don't say SSS, you say side, side, side. Side, side, side postulate. Any question? Are we good? Right, so this is a postulate. You don't have to prove this. So, like I said, on your homework tonight, they may give you some pictures like this and then ask you to write down the congruence and ask you by what postulate, right? What are they congruent? Yes?
So like instead of writing the whole thingy, we just have to say, yeah.
Exactly, because it has name, you don't have to write down the whole thing. You're right. So this one, thankfully, it has a name, right? It's nice. Okay. All right, let's move on to. Before we get to another postulate, let's talk about this for a second. Hold on. Can somebody read this for us? Sometimes. Go ahead, Austin.
Sometimes it's helpful to describe the parts of a triangle in terms of their relative position.
That's right. So let me ask you this, because this is important in order to understand the other postulates, and there are other theorems coming up. Okay, so especially when we're talking about triangles and things like this. Can somebody tell me AB is opposite of, okay, so the side AB or the segment AB is opposite of which angle, guys? What do you think? Don't say it, just think about it. Which angle is opposite of the segment AB? So AB, can you fill in the blanks? AB, side AB is opposite to which angle? Raise your hand. One person knows? Two? Okay. Not more? Grace? Angle C. How many people agree? She is correct. Why is the answer angle C? Why do we say that AB is opposite of angle C there, like this? Jason? It's on the opposite side. That's exactly right. All right, so it's nothing difficult, okay? Just look at this angle right here, C. Look at the side AB, go to the opposite, right, of that side. There is an angle C, right? What about then side AB is included between which two angles? Raise your hand if you think you know. Side AB is included between which two angles? How about Bomon? What do you think? No, I said side AB is included between which two angles? Oh, okay. So there's the easier way to say, you could just use one letter. Yeah, angle B and A. It's nothing hard here, okay? Do you understand? Included between, right? What about then angle A is opposite of which side? How about Iveta? What do you think? Angle A is opposite of which side here? Looking at this triangle. Side BC is correct. Is this easy, guys? Look, angle A is, look at the angle opposite of it, right? There's BC. Yes? Okay, angle A is then included between which two sides? Angle A is included between which two sides here? How about Josh? Yeah, side BA and AC, okay? They use A first because, you know, angle A is there and it doesn't really matter, but so it's sort of nice to use that A first. Okay, so side AB and side AC, that's where the angle A is between. Right? Any question? All right, so why do we talk about this? Because the next postulate is going to use these sort of things here. Question? So what do you think the next postulate is? They're going to come up with. So which three things do we need? We first have side, side, side. What about Naomi? Side, angle, side is correct. So write this down. Okay. By the way, do you think the order matters?
No.
Actually, for side, angle, side, it does. So you don't want to use S side, side, angle. Okay.
Or angle side.
We never say it that way. So we just say side. We don't want side, side, angle. Does that make sense? Okay. The order matters. What kind of angle do you think this angle is? It has to be the. It has to be what kind of angle? Huh? We just talked. Look at.
Opposite.
No.
Opposite.
The angle has to be the. No.
Congruent, in between.
Raise your hand. Don't just. Tony.
Angle between the two segments.
And what do we just learned that? What do we call that? Yeah. What kind of angle is this called? We just learned this, didn't we? If the angle is between these two sides, what do we say?
Adjacent.
Yeah. No, it's just angle. No. Okay, look what it says. If two sides and the included angle. You guys remember included angle? We just talked about this, didn't we?
No. Oh, in
Here, right up here. All right, right here. You see, A is included between side AB and AC. Okay, so that's why we showed you all these. So the angle has to be the included angle. Does that make sense? Otherwise, it will not work. Okay, it doesn't guarantee you that the two triangles will be congruent if you have side, side, and angle. Okay, that won't work every time. Okay, so you have to have side, angle, and side. And look what it says: if two sides and the included angles of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Okay. So that side must be the that angle must be the included angle. Okay. And again, here's some examples of two triangles being congruent because of the side angle side postulate. Okay, so I'll give you time for you to write down the postulate. You don't have to draw the pictures, okay?
I just repeated.
So then who could state the congruence for me? The first triangle. First two triangles. Triangle ABC is congruent to triangle what? Raise your hand. So this is stating the congruence, remember? So ABC is congruent to what triangle? How about Jonathan? FGH. How many people agree with Jonathan? How many people disagree? Okay, he is correct. And most of you are correct. Okay, well, what about triangle MEL? This one's a little bit different because, you know, the first two triangles they're easy. They're just side by side. This one is sort of flipped, okay? MEL triangle. So who could state the congruence here? MEL is congruent to, how about, who haven't I called? I haven't called Eamon. Huh? ODY is correct. Okay. Okay. Does that make sense? Hello? Do you guys understand? Okay, so do you see how the M is the corresponding vertex to O? Right? M and O are the corresponding vertices. How could you tell? Well, look. What's the measurement of the side opposite of M?
9.
What about what's the angle opposite of the side that has length of 9? Oh, you see how you can see those are the corresponding vertices. That's how you could tell. Does that make sense? Okay. Any questions? Okay. And you want to guess what our next postulate then is? We have side, side, side postulate. We have side, angle, side postulate. Which three things can you choose so that it guarantees you that you have a congruent triangles? Who haven't I called today? How about somebody I haven't picked today? How about John? Angle, side, angle is correct. So this is our third postulate. And I'm sorry, here we go. And as you can see, what kind of side do you think we need? We need the, again, included side. Does the order matter? Yes. If you want to use this postulate, angle, side, angle, you need to have this order, okay? Right. Even though this one's sort of interesting, we'll talk about this later when we talk about a theorem. Okay, so write this down. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent, okay? And here are some examples. Move this up a little bit. Okay? So write that down. Then who can tell me the congruence? Who can state the congruence for the first one? First one is always same, isn't it? ABC is what, everybody? Okay, so that's easy. Okay, so what about the next one? MON is congruent to, who could tell me? How about, raise your hand. Who haven't I picked today? I haven't picked. Kristen, what do you think? KEY. How many people agree with Kristen here? KEY is correct. Monkey, okay? Any question? Again, does the order matter? Can I say this? MON is congruent to KYE? No, then you get it wrong, okay? Please be careful. Does that make sense, guys? All right, we get the idea? So how many ways have we learned so far? To show that the two triangles are congruent, you know 3 ways. All right, then what I want you to do is let's prove this thing here. So I'll give you some time, okay? You can work with your group too. Hold on. All right, hold on. Okay, guys, listen. Shh. Okay, so I want you to just write down the given and prove and then the picture and prove it. So it says E, given, is the midpoint of MJ. And TE, the shared side, is perpendicular to MJ. If that's true, how do you show that triangle MET, one on the left, is congruent to triangle JET? Okay, go ahead, everybody try. Actually, let me make it easier for you. Just fill in the blanks. Okay, go ahead. All right, go ahead. So your homework is going to be something like this. It may not give you these fill in the blanks. You may have to just do one yourself, but let's start with this one. Okay, go ahead, everybody try. Yeah, write it down. Good. So first, of course, the reason is because it's given that E is the midpoint of MJ. Now, after you say that, they said something is congruent to something, and it's natural, isn't it? After you say that E is midpoint of MJ, what are you going to say next? Raise your hand if you think you know what to write there. Brandon?
Line segment SUE is congruent to line segment EJ.
ME is congruent to EJ. How many people wrote that down? Raise your hand. Because of definition midpoint? Almost, but it'd be nice if you were to actually do this correctly in terms of matching up with the corresponding vertices. So, Brandon, if you say ME, what should you say? JE, right? JE, right? Because M, right? The corresponding vertices are the M and J. So you're right. So you should write down ME is congruent to segment JE, right? Yeah, do it that way because I want you to be aware that these are, we're trying to.
But it's gonna be wrong. They're congruent.
Right. Not really, but I think it's a good idea. But since we want everything, okay, so I won't take anything off if that's all you did, but try to do it that way because we want to try to keep everything in sort of, right? Okay, so now next, some people are having trouble with the third reason. This could be really difficult if you don't see this. T is perpendicular to MJ. What's the reason? Yeah, if you don't realize that was given to you, then you're gonna go, how am I going to do that, right? It's impossible. So please, just because the given is on the second line, right? The second part is still given. Is that okay? Yeah. That's given. Okay, that's good. All right, then what about for the fourth step? Again, it says, it doesn't say the measure of MET is equal to measure 90, and then measure of JET is 90, and then they didn't go all the way going, because they have the same measure, they're congruent by definition of congruent angle. They didn't do it that way. They just did it with one step. Who knows how to do this in one step like this, instead of saying that the measures are 90 and then that they're congruent because they have the same measure. How about 4 people, 5 people, that's it? No one else? 6 people? All right, Samantha, what did you write? If 2 lines are perpendicular, then they form congruent adjacent angle. How many people agree with that one? Anybody have a different answer? She said say it again.
Two lines are perpendicular.
Hold on, listen. If two lines are perpendicular, then they form congruent adjacent angles. Anybody have a different answer? Good, because that's the right answer. All right. So that's the reason. If two lines are perpendicular, then they form congruent adjacent angle. You see, with that theorem, you can say this straight, right? From here to here. From, right? What we had up here. From third step to fourth step. Right? It saves us a step or so. Okay, number 5 then. TE is congruent to what? One? TE, why? Reflexive property. Why do we even need to include that in there? What's the point? You know, I mean, like, we know, of course, T is congruent to T. Right, let's go up here, right? Don't we know T? Why do we need to say that? Go ahead, sir.
Oh, because for the next step, you need to.
Right, why? Yeah, you're right. For the 6th part, what's the reason, guys? Why are these congruent? Side angle side. So why is that 5th step needed? Can we just see that T is congruent to T? Why do we need to say that there? One person? 2 people? 3? We've been sort of doing this before. Like, even though it may be really obvious to us, we have to say this. Why? Especially in this case. Josh? Kind of. Austin?
Because it's a common side and you need to make sure.
All right, why do we have to measure, why do we say that? Especially if you want to say, what do we want to say at the end? Jason?
They share a side.
Right. I see that. I know. And there, yes.
You're gonna say that their side equals side.
Yeah, say it again.
Side equals side.
Yeah, at the end, you're going to say, because of side angle side postulate that two triangles are congruent, right? But, so I know, but why? Why do we need to say that 5th step? Who could explain a little further? Samantha?
Because you've already proven that two sides, that ME is congruent to EJ, which is one side.
Right.
And you've proved that the angles are congruent, so that's an angle. And then you want to prove that one more side.
That's right. How many things do you need in order to have side angle side? 3 things. So here, on the 2nd step, didn't we say ME is congruent to JE? And here, didn't we say these 2 included angles are congruent? Is that enough? No, you have to have the 3rd side congruent. Even though they're sharing the same side, you have to state it in the proof. Does that make sense? Because side angle side requires for you to have 3 things, 3 parts, right? Congruent parts, 3 corresponding parts, which are the side, angle, and size, right? You have to state it in your proof. If you don't, then the proof isn't complete, even though it may be really obvious to you. Does that make sense? So the 5th step is necessary. Does that make sense?
Yes.
Any questions? Okay. All right. So can you do something like this for your homework tonight? Yes.
Yes.
Okay. Good then.
Are you done?
Yeah. Okay. Let's review a little bit. So there are 3 things we learned today. What are the 3 postulates? First one was? No, it was side postulate. That's one way to show that the 2 triangles are congruent. What's the second way?
Side angle side.
Good.
Angles.
And angle has to be the included angle. And Jonathan, what's the third one?
Angle side angle.
Angle side angle. Right? And then the side has to be the included side, right? There is actually one more. Even though we haven't learned this today. There's one other way of showing that the 2 triangles are congruent. No, it's something we learned actually last time. Yes, sir? That's wrong. If you use angle, then the 2 triangles are not necessarily congruent. This is, guys, listen. So it looks like there are 3 ways, right? Turns out we learned one more way of showing that the 2 triangles are congruent. Not today, but yesterday. Iveta. No, what do you mean by that? We haven't learned that. Who thinks they know? So there are 3 ways of showing, right? We know these 3 postulates. There's actually one more way of doing. Yes, Nicole? We haven't learned that.
I know.
That's only for right triangle.
I remember.
Yes.
If the vertices match.
Almost. You're getting closer. You're getting closer. Jonathan? We haven't learned that. I'm telling you, we haven't. That's not true every time. Side angle. We don't even have that. We haven't even learned it because that's not true. Okay, side angle doesn't work. Samantha? Yes. That's the no. That's just a statement, but little bit further. What is that you're using if you're going to do this? Yes. Definition of congruent triangles. How many parts do you have to show? 6. If you show all 6 parts, then you know that the 2 triangles are. But would you do that if you know the other 3 ways?
Yeah, no.
No, because we know we could cut down our work in half, right?
Yes.
Instead of using definition, we could use side or
Side
angle side or
angle side.
angle. Does that make sense? But you could use a definition and show all 6 parts are congruent if you wanted to. Does that make sense?
Oh.
Yeah, but you wouldn't do it normally. Any question? Does that make sense?
Yes.
All right.